Here's another permanent magnet. I've labeled the direction of the magnetic field. So there's a magnetic field coming out of the end of this. All right, so now this device here is making a beam of electrons. So it's a little bit complicated here, but what this is a high voltage power supply. So it's got tens of thousands of volts. And you see we have on this end, we have the positive lead. On the other end, we have the negative lead. So what's happening here is that this tube over here, the glass tube, is pretty much empty. There's very little gas in there. But the electric field is so strong that the electrons get released from this side and go streaming across to the other side. There's no wires connecting one end to the other. They're just going across the space in between. Now, what's not so obvious here is that there's a piece of metal here blocking the way, and there's just a narrow slit through which the electrons can go. So what we get is electrons coming out of here, hitting that plate, but the only ones that get out is the sheet of electrons. Now what we're actually seeing is the electrons hitting this screen here, which is covered with phosphorus, so it glows green when the electrons hit it. Okay, we have to think that there's this sheet of electrons going like that, and they run into it. Now what we'd like to do is see what happens when we put a magnetic field near it. Okay, so I'm going to take the magnetic field here, and it's like send the magnetic field at it. I don't know if you see, but the electrons get deflected down. Okay, if I turn this around so the magnetic field is coming towards us, the the electrons get deflected out. Okay, so I've tried to draw some down below here. This velocity is the velocity of the electrons, but the current, since the electrons are negative, is actually going that way. Okay, so just try to remember this. We'll write it out more clearly in a second when we can. But in the demonstration, we see that when the magnetic field is coming towards us and the current is that way, there's a force upward on the current. If the magnetic field is going away from us and the current is going to the left, then the force is down. Okay? The important thing here is the force is perpendicular to both the direction of the magnetic field and the direction of the current. Okay, so the field was horizontal, the velocity was horizontal, but the force is up and down. Okay, we can see this same thing over here. This is a little less noisy. So all this is another power supply. And I'm going to put the magnetic field there next to this wire. So I'm going to make a current in that wire. So let's just hook it up here. Turn on the power supply. So if I plug this in, it's not plugged in yet, we'll have a current in there. So first off, notice that the magnet doesn't do anything to this unless I touch it. It's not causing any forces. But if I put a current going through there, and now I bring this over here, you can see, get a better vantage point here. I'm not touching it with the magnet, but the magnet causes it to move. So let's try this a little differently now. So we're going to put this here. And let's try to get a good viewpoint here. So the wire is just kind of sitting on top of that, but it has no current. And so I'm going to turn it on so that, we get our arrow here. Sorry. So the current's going this way. Okay, so it comes out of here, the current comes out of there and through the wire. So now when I plug it in, watch to see which direction the force is. I see it came towards us. Okay, so now think about what we have. The current is this direction, the field is that direction, and the force was that way, towards us. Okay? Again, they're all perpendicular to each other. The force is perpendicular to both the current and the magnetic field. We can change the direction of the current by switching these wires around. So we'll switch the polarity. So remember, before the wire came towards us. Now we'll watch it from up above here. I can plug it in here. You see that pushes it backwards. Okay, so that flips it. Yeah. So now the current was going this way. The field was up and the force was back. Okay, so the important thing here is that it's perpendicular. Okay. So we have these two vectors here, they make a plane. And then the force is perpendicular to that plane.